Edexcel Pure Core, Hyperbolic Functions 2, Inverse Hyperbolic Functions. Integration using inverse hyperbolic functions. We've previously seen that the derivative of the inverse of sin x is 1 over the square root of 1 plus x squared, and therefore we can conclude that if we integrate both sides, so the integral of this derivative would just become the inverse of sin, then we can get this very helpful integral of 1 over the square root of 1 plus x squared. Likewise, we've been previously differentiated the inverse of cos x, and if we integrate both sides we can get a different kind of integral. So we're just using that integration is the reverse of differentiation. Don't forget the constants of integration. These will be found in your formula book, and they allow us to integrate these new kinds of functions which we haven't looked at before. So these are the more generalized cases. So rather than just have 1 plus x squared, then we have a squared plus x squared and x squared minus a squared in this one. So when we're doing these problems, the things to look out for is it's very helpful if the coefficient of x squared is 1, which will make it easier to apply these formulae, and if we clearly state the value of a before we quote the result. And we're going to look at these types of issues in the next couple of examples. So here, the only thing I'd do here, a couple of things before I start. I would rewrite this as 1 over the square root of x squared, and I might write it as 5 squared just for emphasis. Do check, by the way, that there is just a 1 in that numerator. Sometimes it might be a 2 or a 3 and we need to adjust the answer, but I can now clearly see that a is 5 in this particular question, and therefore I can write the result as r cos, and there's only 1x squared in here, so it's an x over a, which is 5. Don't forget the constant of integration. However, in this integral it's a little bit more complicated. So here we're going to integrate 1 over the square root of 16 plus 9x squared. And my first concern is that 9x squared. We really could do with the coefficient of x squared to be 1. So the first thing I would do here would be to rewrite this problem, and I would pull 9 out of this denominator, so it's 16 over 9 plus 1x squared dx, and now we've achieved the 1x squared, which is extremely helpful. I can also rewrite root 9, so we're going to have 1 over root 9, which is a third, so I'm going to pull that outside the integral sign. And the other thing I would do at this point is perhaps to rewrite 16 over 9 as 4 over 3 squared plus x squared dx. So I've definitely got 1x squared there, which is very helpful, but I can also identify that a is now 4/3. So not forgetting the third at the front of this integral, I've now got it in a form where I can quote the result as r sin x over 4/3, which is the same as 3x over 4. Not forgetting the constant of integration. So just a reminder, a couple of key steps here. It's the coefficient of 9x squared is 9, is a little bit of a problem, so I pulled 9 out of that denominator, and the square root of a ninth became a third, but more importantly we ended up with 1x squared. I also could identify a as 4/3 before quoting the nice simplified final result. In the next video we're going to be looking at integration using hyperbolic substitutions.